Pluto rediscovered by the James Webb Space Telescope. For decades, Pluto lived on the margins of human imagination. It was cast aside as little more than a frozen leftover, a wandering speck at the solar system's edge, too small, too cold, and too distant to matter in the greater cosmic tale. When it was reclassified as a dwarf planet in 2006, many believed its story had ended, that it was destined to remain nothing more than an icy footnote in astronomy's vast ledger. Pluto seemed to embody silence. It was pictured as a relic of creation, an abandoned shard of rock and ice circling endlessly in the darkness, devoid of movement, atmosphere, or meaning. In textbooks and popular culture alike, it was painted as an outsider, a forgotten child of the solar system. And then came the James Webb Space Telescope, JWST, a machine that changed the very way humanity gazes into the heavens. Built with precision beyond imagination, armed with mirrors of gold and instruments capable of sensing the faintest whispers of starlight, JWST was designed not only to look far back in time, but also to reveal hidden truths about worlds much closer to home. When this technological marvel turned its gaze toward Pluto, expectations were modest. After all, what more could be learned about a frozen body drifting billions of kilometers from the sun? Yet what JWST uncovered was not emptiness or stillness, but complexity, beauty, and a story far richer than anyone had dared to imagine. Pluto was no longer the barren, lifeless rock of old assumptions. Instead, it was revealed as a dynamic and evolving world, a planet, dwarf though it may be, that carries within it the fingerprints of activity, chemistry, and perhaps even habitability. JWST's powerful eyes uncovered immense plains of shifting nitrogen ice, surfaces that appeared to flow and reshape themselves with Pluto's slow, elongated seasons. It revealed towering mountains sculpted from solid water ice, monuments that rise like frozen giants, etched into strange forms by processes scientists are only beginning to decode. And scattered across the surface were deep crimson stains of tholins, organic compounds born when ultraviolet sunlight collides with Pluto's fragile skies. These chemical markings not only paint the surface in haunting shades of red, but also whisper of chemistry that may resemble the earliest ingredients of life itself. Even more extraordinary was the suggestion of something hidden far below, a subsurface ocean of liquid water, locked beneath ancient layers of frozen crust. If this ocean exists, it may have persisted for billions of years, sheltered from the freezing void by Pluto's inner warmth. Such endurance raises an astonishing possibility, that Pluto may not simply be a frozen survivor, but a living world, holding secrets about life's resilience in the unlikeliest of places. This revelation transforms planetary science itself. For generations, astronomers believed habitability required the sun's warmth, restricted to the so-called Goldilocks zone, where liquid water could endure. But Pluto challenges that notion. Here, on the farthest frontier, a small, icy world demonstrates that heat, chemistry, and perhaps life may emerge in places long considered impossible. JWST also shed light on Pluto's delicate atmosphere. Thin yet restless, it is made of nitrogen, methane, and carbon dioxide. Unlike Earth's steady blanket of air, Pluto's atmosphere is unstable and ever-changing, expanding and collapsing dramatically as it follows its stretched, elliptical path around the Sun. It is fragile, mysterious, and unlike anything else in the solar system, a natural laboratory that shows how worlds adapt to the most extreme conditions imaginable. Every new image and spectrum from JWST reshapes Pluto's identity. No longer is it a forgotten relic or a discarded planet. It has become a world alive with activity, a cosmic puzzle filled with questions that reach far beyond its frozen horizons. Pluto now stands as a reminder that even the smallest, coldest, and most overlooked places can hold wonders vast enough to implications, mysteries, and the future of Pluto exploration. The discoveries made by the James Webb Space Telescope, JWST, reach far beyond Pluto itself. They invite us to challenge assumptions about habitability, resilience, and the surprising endurance of icy worlds drifting in the farthest shadows of the Sun. At the center of this mystery lies Pluto's subsurface ocean, sealed beneath a crust of frozen ice. On Earth, we know that entire ecosystems thrive in the pitch-black depths of our oceans, surviving without sunlight, sustained only by chemical energy from hydrothermal vents. If similar conditions exist on Pluto, then microbial colonies, or perhaps even primitive ecosystems, could still endure in its secret waters today. The confirmation of even the tiniest organism would prove something extraordinary. That life is not an Earth-only phenomenon, but a natural pattern that may emerge wherever chemistry, water, and time combine. Another enigma is Pluto's unexpected internal heat. Although nearly 40 times farther from the Sun than Earth, Pluto remains geologically active. This warmth may be fueled by the slow decay of radioactive materials deep within its rocky heart, amplified by the subtle gravitational tug-of-war with its largest moon, Charon. Together, these forces act like a hidden furnace, preventing the underground ocean from freezing solid. Such persistence forces scientists to reconsider what makes a world alive and active, even in places once believed to be permanently frozen and inert. Pluto's atmosphere deepens the intrigue further. Composed mainly of nitrogen, with traces of methane and carbon dioxide, it is anything but stable. It grows, thins, and collapses dramatically as Pluto travels its stretched orbit around the Sun. This repeating cycle, unlike anything witnessed elsewhere, transforms Pluto into a natural laboratory for understanding how worlds adapt to extreme, shifting conditions. The implications extend far across the solar system. If life can endure within Pluto's hidden ocean, then it may also exist on Europa, Enceladus, Titan, and countless other icy moons. Suddenly, the search for life is no longer confined to Earth-like planets orbiting in the habitable zone of stars. It stretches outward, suggesting that habitable environments may be scattered across the galaxy, buried beneath frozen shells on worlds once dismissed as barren wastelands. Looking toward the future, scientists are developing bold mission concepts. Ideas include orbiters to chart Pluto in exquisite detail, robotic landers to probe its crust, and even autonomous submarines designed to explore its concealed ocean. Such missions could finally confirm whether Pluto harbors life and reveal how a small, frozen world has managed to stay geologically alive for so long. The discovery of even microscopic organisms would stand as one of the greatest milestones in human history, forever reshaping our understanding of biology and our place in the cosmos. Beyond the possibility of life, Pluto offers insight into the earliest steps of planetary chemistry. Its surface, tinted crimson by organic tholins, may carry the building blocks of biology. If these compounds mix into its buried ocean, they could ignite the first sparks of prebiotic chemistry, the early whispers of a path that might one day lead to life. Pluto has transformed from a forgotten icy outpost into a beacon of possibility and exploration. It proves that even the most distant, cold, and overlooked worlds can hold astonishing secrets that challenge everything we thought we knew. In conclusion, JWST has revealed Pluto not as a frozen relic, but as a living, evolving world with the power to reshape science and ignite imagination. Its mysteries urge us to return, through orbiters, landers, and one day perhaps even robotic submarines, to peel back its icy crust and uncover the truths that lie within. Pluto now stands as a reminder that the universe is far richer, stranger, and more filled with possibilities